Hello everyone. Let me first give you the guideline. I will make an announcement of your final exam. You can find out from your Blackboard. So this is your class Blackboard. And if you click announcement, there is a final exam plan. As we did for your midterm exam, there will be 3 time frames set for Sunday, December 18th, Monday 19th, and Tuesday 20th. You can choose one of those 3 days for 3 hours. You can come to Blackboard to complete your final exam. Only one sitting allowed. So once you start, you have to finish and submit it. Otherwise, there is no credits that I can give it to you, and all of this is your responsibility. And I know that every one of you already had the experience. Because this is the final exam, there is no makeup. Immediately after this exam, I have to submit your letter grade to the college. Right? Please keep in mind. The final exam will cover from, this is a comprehensive exam, which means covers from the first lecture to the last lecture. Sometimes, well, I probably not, but the thing is this, more materials will be asked, covered after the midterm, but few questions will be taken from your midterm exam. Okay. Those who do not have reliable internet access, I want you to find out a place so that you do not have any disconnection during you are taking your final exam. And also there will be the last homework assignments. If you click the course material, then I just posted in response to one of your classmates requested. 2 questions basically are asked on your homework, the last homework. You have to download a file called the Linux distributor.txt from sitesecure.org, which is our program web server. You can click on it, or let's try what it is. If you go to sitesecure.org, by the way, a little bit updated from the previous, and there is a course IASP 321, and I want you to click the first item, list of Linux distributors for IASP 321. If you click on it, then there's multiple columns of the tables. When you open your Linux operating systems, for example, and if you work on VI mode, then click VI and type ll.txt, for example, and open up and press I. In that way, your file will be ready for insertion. See here, insert indicator appears on the lower left corner of your terminal. Okay. And then what you can do is come back to the sitesecure.org web page. You can simply highlight all by pressing Ctrl and A, and then copy it by holding down Ctrl and press C for copy. And then you can come back here and here in Linux operating system, particularly in VI editor, if you want to paste the content in the buffer, you need to press right button of your mouse, then everything will be pasted. Watch this. I'm going to click right button. Alright, and after this you have to press escape button. Don't forget to press escape button whenever you do completing all the editing. And if you're ready to save or save and exit, then you have to do escape button and then shift ZZ, or escape button colon W exclamation mark. That will also work. Let me show you. If you press colon here, then see here lower left corner there is a colon appears, and then W, small W for right, and exclamation mark. Then this content, the content you just pasted, will be saved. See, there is a the message. It says ll.txt new and 81 line and 9,942 character written. Okay, that is the message that you can see. If you save the file using escape and colon button, or you can simply again escape in uppercase ZZ. Alright, so what you have here, if I do cat ll.txt, then that's the file that you can see here is the same as there, right? So let me go back to the homework assignments. So once you have that, this one has multiple columns, right? The file that you just downloaded has a lot of multiple columns. What I want you to do is to slice out first two columns and also fourth to sixth fields means columns, okay, and then paste them together. All right, and then submit it. So that is the exercise, few techniques that we discussed before Thanksgiving, okay? So today we will do, in addition to that issue, this is a little bigger homework assignments. And the other one I'm going to cover today. So you need to look at the textbook, page 229 and 231. And what I want you to is that, so we'll see that what I mean by this. So generate 1,000 phone numbers. You can generate automatically 1,000 phone numbers, and find out all the numbers, all the phone numbers that start with the 9. So 9XX, and followed by 5XX-XXXX. So one of my cell phone number, for example, so 914-582-3659 will be matched and returned. There are a few of those. If you randomly generate 1,000 phone numbers, I'm sure. If you do not have, unfortunately, then I want you to increase the sample numbers from 1,000 to 1,500 or 2,000 until you see some matches. Okay, I'm sure you will have a few matches to be returned. And then how can you select those numbers with two restrictions? Only the area code 9, and then your number start to, with 5. You have to express the pattern of this using regular expression. Okay, so the regular expression that you use successfully to select such numbers should be submitted. Okay, so what you need to submit is screenshots of your program execution and file produced, for example, question number 2. Okay, and then regular expression that you used for question number 3.c. All right. Now let's go back to the class material for today. All right. This course material already posted, so you can take a look from Blackboard. So we're going to cover chapter 17 and 19 today, 2 chapters. So those 2 chapters are very, very important and useful for you to do Linux operation activities. Some cases you want to find out some files from the systems, right? So that is discussed in chapter 17. And furthermore, you may want to find out some files which contains some of the content that you want to look for, right? That is discussed in chapter 19. Chapter 19 is a really sophisticated technique in a way that you do not need to open every single file to find out some of the symbols that you want to find. Still, using your script, you can find them automatically. Okay, that is very, very useful tool, useful language that you can use for example, I want to see some of the files modified since such time. For example, some hackers come in your system and change out some of the files, which you do not know, right? But by having some Linux commands or putting into a script which will be running automatically, then find out periodically, which is handy. Right, those 2 things will be discussed today. So first command that we'll look at is find. Okay, find is the command that'll find out some of the files from the directory. One of the directory here is a tilde. Tilde is a directory of your home. Okay. Similarly, // is the root directory that is on top of your file system. So let's take a look at each of these in a little bit of exercise. This is about chapter 17 and this is chapter 19, which is really a busy slide, right? Alright, so I'm going to bring up here right? And as you can see, I already logged in through VPN. Hopefully you could do that too. And if you find, for example, let's do, find where am I right now? So if you type pwd, then it'll print the working directory, which is /home/jeyun right now, right? So let's try to go up to the top by change directory to /, which is the root directory. So pwd, then it will return /. So I'm not in my directory. So I am somewhere. And then from there, if you want to see, oh, what is my, what's in my home directory, then you need to do find, and tilde is your home directory. That is a symbol, right? Then it'll return all the files in your home directory. Not only that, find is a command, search all, for example, research is the directory under my home. That research directory contains multiple other data, right? So it searches recursively all the way to the level of the files. So if there is a directory, then open that directory and go deeper and list all the files. There is a command find, right? So find is good, and the result of that will be piped with word count WC. So I want to see how many lines there. So WC and -L for line, then it'll give me the number of lines of the resulting matches. Okay, so 284 matches. If we want to see, for example, WC minus C, then 7,225. If we want to see what do you mean by those options for word count, then you can see man for manual and WC, and you can see some of the options. The /C, that is the one that I used, is to print the byte counts. So what it returns, or what is piped to, will be counted and returned the number in byte. So you can see how many bytes. Similarly, -L, that is for lines. So how many lines in the outcome. Okay. The other one is that I want to see, for example, find back into my home directory. I want to look at only file, then -type, followed by F for file. And if you want to see, if you are interested in particularly, for example, TXT file, then you need to see here star, there's a wildcard, which means it can be any character, any numeric, alphanumeric data in any repetitions. So it could be anything dot txt file. Okay, so what I want to find here is the file with the name ending with .txt. All right. So watch that. And I have quite a few of those. Sometimes, I want to see how many, and can see WC and -L, then it'll give you, oh, there are 24 files, 24 text files, for example. Okay. And another option for find is mmin, which is very useful for your cybersecurity management. For those who wants to see more, then I will point you to the place that you need to find out, which is the page 191, table 17-3. There are a list of options. So I wanted to read those options in the table. They are very, very useful for you to use, not for this class, but in your future career. For example, in the middle of the table, there's a -mmin followed by number, which matches files or directories whose contents were modified n minutes ago. And line below, -m time, which matches files or directories whose contents only were last modified n times 24 hours ago, which means n days ago. Okay, n minutes ago or n days ago. What will help you is that as an administrator, let's say you know which files will be modified for the last couple of weeks, but unknowingly, supposedly a hacker comes in your system and modify some of the files, and still you can find out automatically by issuing this kind of command. Okay, so let's try some of this here. So I want to find out all the files in everything within my system. So find the slash and then -m time for last 24 days, last 30 days. Okay, last 30 days, I want to see any files modified. Then it'll return. Okay, watch. There are so many files permission not granted, but don't worry about it. We can fix it. There's a boot directories and so on and so forth. Let's stop this. It's too long. What you need to do is, because you do not have permission, I do not have permission, what do you need to do? Sudo, right? Sudo. And then not last 30 days, let's do last 10 days, because it matches to me. And hit, then it'll ask you to enter your password. Very nicely, it shows all the files that were modified since the last 10 days ago. There are a lot of system files. Some of the files supposedly to be modified, some of the files not necessarily, or some of the files illegally. So you can see those. So many matches, right? So this is one of the things that you can use handy. You can specify a little in detail, specified specific directory, not all the directories from the top, for example, etc, then much best, right? etc. Those, how many? Those files. All right. And another thing is that, okay. So find command lists you the files that you want to look for. But in some cases, you may want to take an action. Not only see the list of the matches, but you want to take an action on your finding command. Then there is an option -exec followed by the command. All right, and this exec option, because this is action, list of action, this action should end with a semicolon. If you don't do semicolon, then that is incomplete action description. So you have to do semicolon at last. And if you want to have a plus sign, then which means you can do a series of actions in response to your find command. Okay, so -exec followed by any action command. So there will be another Linux command. And then don't forget to put open curly braces and close within quote. All right. So for those who are interested in this and need to see more, then you can do man find, and somewhere there it explain about execution. Okay, action execution. So see those all. Another thing is this is also interesting ones, right? I want to see any empty files, right? Then -empty. This is also good. Mmin, mtime, that's what we looked at a few minutes ago. And newer, which is good also. Any files modified more recently than file. So you can provide a file, and then if you give an option -newer, then hey, I don't want to see any files that have been modified since the file that I created, which is good, right? And POM, I want to see a files which has this access mode. Okay, so meanwhile, unknowingly, if somebody changes some of the actions, access mode, so that open files for public access, which is not what you want. How can you find out such files? Then you need to do this option, -POM is a permit options. Okay. Another thing. You can find out by size of files. And some of the files are used, not modified, but used. I want to see anybody used this program since 5 days ago, which is good, right? So dash used followed by number n, which is in days. So you can find out files that has been last accessed n days after its status was last changed. And username. Okay, and those some of the options that you can use to find out, and then in this manual, and then list of actions that you can take. Delete. Once you find any malicious files from your system, and if any files found, then if you want to delete it automatically, immediately, then you can take these actions, minus delete. Then that file will be deleted as it is found. Similarly, there is minus exec followed by command. This is the one that we just looked at in this slide. All right. If you have a series of actions, then you need to have command and plus sign. If you have simply command and then you should have semicolon. Okay. So I wanted to find out, this is a long list, which is good, right? Find. So find is a very, very powerful command that you can make and check and take actions automatically in your system. What I want to do here, another one here. Oops. This find statements, find tilde and backslash and open parenthesis. And if you see, then there is a backslash and close parenthesis. And the comment that I give to you here is, that is nothing but escape character. What I mean by here is that open and close parenthesis is a special character. Special character. So in your regular expression, it means something. Okay? Particularly, parenthesis means a grouping of some of the expression, like in mathematics, right? But what if you do not want parenthesis as a special character, but parenthesis as is? Okay? You want to match the parenthesis as is. Then you need to put a backslash. So backslash in this case means escape character. I want to escape the following character from whatever the agreement that we make in this language. That's what we want, right? So if you see this find, I want to make here find is a complicated expression with a connector or. Okay, for example, A or B. Right? I have two different pattern expression and connect them together. As a whole, that'll be a condition, or condition for finding. So I have here -or, which is Linux command for this. Well, this is option, right, for find. So find A or B. Okay, A, which is in parentheses. So actually, if it is not a specially, if it's not the character specially designated for regular expression, it should be like this. I want to find the type, but not the permission 600. You know what 600 means, right? 6 means 1 plus, what is that? 600. 1, 2, 4, right? 2 and 4. So 2 and 4 means 6. So 4 means read, 2 means write. So any files that do not have read and write permits, that's what I want. Okay. But I want to say or that condition, or type is directory, which is D, but not the permit perm 700. This is similar on that. And this is basically what I want. But when I type this, then it says syntax error near unexpected token. So the parenthesis is a token that is pre-designated for special consideration. But that's not what you want. What you want here is to simply use a parenthesis, right? So first parenthesis or the second parenthesis. How can you make it? So I want to escape that special character. We call that meta character. So parenthesis is not anymore a meta character. I want to escape it. Escape that guy. Open and close all of those. Okay. I hit enter. Then it returns. Right? Alright. Within my directory. Right? The last one, see here we have VAL and log, anything in VAL directory, which is the files a variable in size, usually under that directory. So many data files are stored in that directory. Data that is dynamically, gradually updated, are all under this directory, and one of those files is a log file, right? So if I do log ls/var/log, then returns all the log files. They are not all, but a few of the log files. Against that log files, if you want to do, for example, find var log type f, so I want to find the file, and name, only the name, for example, star.log. Actually, yeah, there's a few of those log files, but I want to do execute and echo whatever returns, and I want to end it. When I do this, then I have that, all the log files, right? I have one permission denied, so if you want to do sudo, then you don't have that error. See here, I do not have that. Unattended, I have 3 matches under that directory. So so I wanted to follow the textbook, the way that I give you a sample lecture here, but I want to move to another module, chapter 19, regular expression, which is very, very useful. Again. Okay, what is a regular expression? Regular expression is a symbolic notations used to identify patterns in text. So, as I said earlier, if you want to find the files from your system, then you can use command find. But if you want to do a little further, looking at the inside of the files, then you need to express the RE for regular expression. Which one of the simple command to do that is grep. Okay, I want to grab the files which contains either the text that I explicitly specify or the pattern that I can give you. So patterns can be expressed in regular expression. For example, I want to see the files which contains phone numbers, but I do not know a specific phone number, but any phone numbers, if existing in any files, I want to those all the files. Or by looking at all the text, all the files which contains email address. I do not care any specific emails. If I do, then I can find out. But what I want is just email address. But we know the pattern of email address, right? If it is email address, then there is the @ and followed by whatever the system name, and then the name ending with .com or .org, .edu, something, right? So some of the patterns there, so we can express, we can generalize it. So we can say, hey, whatever the number, if it falls into this expression, then yeah, that is phone number, or that is country name, or that is email, or that is whatever where there is a patterns, then you can express it and in your Linux command. Okay. Let's try first very simple ones using grep. So when I type cd, right now I'm on top, right? When I type cd, then I can get back to my home directory. And when I do grep and mercy, there's a name mercy, from any files, star.star. If I do star only, then any files, but usually if I do star or star.star, then it's more specifically there is a dot, extension files. But anyway, so that we have these files, or star.star, or if we have or star.data, for example, then I have only those in the file data. Mercy.data has those, or num mercy has the word mercy. Okay, this is very simple regular expression. It's not really a regular expression, but this is a simple way of looking at the content of a file, right? So I wanted to practice some of the commands shown in the text, page 217. There are useful commands that you can do. For example, this is the thing. In the middle of that, ls/bin, and then greater than sign, which is the output of ls/bin, will be written in the file name dir-list-bin.txt. Okay, so you can generate files, 4 files from /bin, /usr/bin, /sbin, /usr/sbin, so that if you see all the files starting with the dir-list, I did already. So if we do that, dir-list, start with the dir-list, but whatever that ending, as you can see in the text, 4 files generated, right? The size of those 4 files can be listed in this way: ls-l, same pattern, right? So I have 4 files, and there, if we want to see grep bzip as an example, and again dir-list star.txt, then you can see those 2 files. Okay, and if you are interested in only the files that contains the matches rather than the matches themselves, then you can specify -l. So if you specify here -l, what happens here is that bzip to cover then -l, which will return only 1. what does this means is that I want to not the individual not the list of all details individual matches, but I want to see the file that contains the string that I want to see. Then of course only one file. One file contains that string twice. Okay, so it may mislead if we don't speak files. But I want to see a unique. I want to see a list of files uniquely, each of which contains this. Then you need to see -L, like this. Okay. Conversely, if you want to see a list of only the files that did not contain a match, then you can do uppercase L. That'll be fine too. 3 of those, right? So those are the things that I want you to do. And then if you turn the page, the first paragraph of the page 218, there's a meta characters. It's a caret, $sign. Those are 2 meta characters widely used, more specifically used to specify the patterns or regular expression. So if you have a caret followed by whatever, then whatever that can be found at the beginning of the line. And whatever you specify ending with a $sign, then whatever you specified should be found at the end of the line. So caret and $sign, those 2 characters used to specify the beginning or ending of the line. And dot, that is, there's not period puncture, but dot means single. There's a current, right? Or a single character. And then question mark, star, plus, those are all something about the occurrence. And square bracket, parenthesis, curly braces, and means something. As you can see here, the square bracket, then whatever within the square bracket will be taken. So any character in X means square bracket encompassed. And if you have parentheses, then everything together within the parentheses. If you have a curly brace and one number, then that is maximum. And if you have 2 numbers, comma in between, then it's a minimum or maximum numbers. So those are explained somehow in the textbook. Okay, 218, 219. All right. So with that, last slide. Okay, the page 226 and 231. So if you turn that, and quantifiers will be used. Okay, anything you say there and question mark, then whatever in the parentheses occurs 0 or 1 time. So question mark means the quantifier 0 or 1. star means 0 or more, plus sign 1 or more, which is very handy and very useful. So one of the examples in the homework assignments, which you need to take a look at we'll find out a little bit later, okay? So back to the same example that we made from var/log directory. I want to grab, for example, a-z within square bracket. What it means is that square bracket, then you can grab anything, right? Anything here, any uppercase. Can we find any uppercase within this dir list.txt? Those are the uppercases. So any number, any uppercases. If you want to do, for example, I want to have only one or more. Let's forget about that. That is this, and then the similar things will be done in this way. Double square bracket, colon upper, and another colon, and close the square bracket. Then it'll return this same result. So the point here is that well, this is not right. This is wrong. It's not right. Any characters within the uppercase. That's what it means. Let me back up. Let's see here. Okay. And I did here the uppercase colon, uppercase colon, which is some of the patterns predefined, is already defined for POSIX. POSIX means Portable Operating System Interface, that has been discussed by IEEE, which is the Institute of Electrical and Electronics Engineers, and that is a standard called 1003. So you can read it, some of the description in the page 225. Basically, the reason behind that we set up a POSIX by IEEE 1003 is because if you look at the ASCII code, the code is designed in this way. For example, first 32 characters are the control code, and next 32 is printable characters, and then next to 32 characters for uppercase with the punctuation, and then last to 31 is the lowercase. So if you see it, the order of those characters, given, for example, the same character, let's say A, the uppercase A and lowercase a, what actually, according to the dictionary, uppercase A and lowercase a should be in the same order, or somehow there is some order near, right? In other words, uppercase A appears earlier than lowercase b, or vice versa, right? Lowercase a appears uppercase b. But if it is not POSIX, which is newly standardized by IEEE 1003, the computers by default doesn't follow the alphabetic order which used by dictionary, but computer has its own order in ASCII code. That is exemplified on page 222. In the middle of that, and some of the characters, right? According to ASCII code, all uppercase A through Z followed by all lowercase a through Z again. That is the order. That is the order. The computer. But POSIX, in other words, dictionary collection order, it should be lowercase a, uppercase a, lowercase b, uppercase b, lowercase c, uppercase c, lowercase d, uppercase d, lowercase e, uppercase e, and so on and so forth, all the way to the lowercase z and uppercase z. That is the order that you can see in regular dictionary. So the question is, can you do that on the computer as well? Somehow, yes, you can do. So that is the POSIX. Okay. So this command is according to POSIX, and those POSIX character classes are defined on table 19.2. Okay, so you can take a look at that. The example of a quantifier. Let's look at, for example, the page 227. Example very on top, echo, and you can say this is phone number 555 and 1 2 3 4 5 6 7. Then they echo. Looks like that is a phone number, right? So that type of phone number can be specified in this way. Let's say grep minus e, so that you can tell that there is a escape function, and then slash open parenthesis, which means I want to use open parenthesis as is, without saying that it means, when it comes to parentheses, without escaping it, it means, oh, I want to group them, right? So I want to, that's not what I want. I want to parentheses as is. So you need to say it in this way, so that you can say oh, that open parenthesis appears 0 or 1 time, and then you can say within square bracket 0-9 means any number within 0 through 9 followed by any number through 0, any number from 0 to 9 and any number from 0 to 9 3 times, right? And then close parenthesis. Again, it could appear or appear not, and followed by and one space and followed by 0 through 9, and 3 times of those. 0 and 9, 3 times of those, right? Ending with those three of those. See what happens. So oh, I'm sorry. I didn't do that. Here, I should say, start with that, right? So, carrot. Okay. So I think should have that. 3 characters ending with that. That is this. That should be matched. And then let's practice a little. Let's forget about starting, but ending. See what happens. Right. So if I say number, and $, therefore 3 numbers. Anything here ending 3 numbers. Of course, that is that, right? So that is matched. You can see the color. In the same way, if we want to make ending with 4 numbers, of course 4 numbers, you can do that, right? Or because this is too much, if we want to do I want to make this I want to make this 4 times. Okay, rather than specifying 4, I want to do within curly braces number 4, then that is number maximum number, right? I mean that many numbers. So 0 and 9, that number 4 times, that matches also, right? And if we want to do, can I see anything start with, which is that, and then open parenthesis. Okay. And then any number in between. So anything in between. see here is, let's see, if I do this, then it doesn't match, because this means if there is anything in this way, okay, then it'll match, because it starts with parentheses and then one space and then 4 numbers. That exactly matched, right? But if we want to do, for example, everything of those, then you can say, okay, 0 to 9, how many of those? 3 of those, and then backslash parentheses, so 3 numbers within parentheses, and followed by 1 space, and then 3 numbers again, so 3 times, and then in between I have slash, right? Then I return perfectly. That is matched, or anything like this, only one open parenthesis, but there is no closing parenthesis. That is also possible, right? That if you want to make it possible, then you should have here question mark, so 0 or more, then it'll match. Again, if you want to say optionally the open parenthesis, then you need to put here question mark, then whatever one before that appears either on 1 time or 0. So that's also possible, right? Even if you have nothing, still possible. Another thing here, if you want to make this zero or more, that is also possible, right? Star means 0 or more. So if you have only no numbers but this, that should be okay, right? Because I said before slash any number, but I said star means 0 or more. That is also possible. So if I put here any numbers, like so many other numbers, that means 0 or more numbers, right? That is also matched. So there is another example on page 229, which is related to your homework assignments, with the for loop, for I in, and there is 1.10. So I want to repeat that for 10 times to do what? I want to do echo, and within that parenthesis, I want to make this is literal, so it is not yet any regular expression, but I want to make open parenthesis and a variable which is in random, 0 and 3. So 3 random numbers generated, and 1 space, and another random number, 3 of those, and slash and dollar sign and another random number, 0 and 3. Okay, if I do, then and then I have to do done. Oops. So what I wanted to go, there's 2 of those. So then I have that, but actually I want to make this 4, if it is phone number, right? 4 of those. I have that many, but I didn't put that close parenthesis, so I have to put here parenthesis. Then I have those. If I want to make 100, then I have 100 of those, right? But some of here is I have only 3 numbers. That is also possible, right? 0, comma 3. That's what we specified. All right. So this may be the phone number that you generate. But in the homework assignments, if I say I want to search 914 or any area code starting with a 9, is there any? Yeah, I have here 9. And then there is another restriction. By the way, the number first number should be 5. Is there any such? 9, 1. If you do not have it, then you have to do multiple times, more and more, right? So that you have. If you have 1,000, definitely you have. Not definitely, it's not guaranteed, but you may have more. Okay? So you need to save this. If you want to save this, then you need to do this within some file name. So you can say my phone book.txt. Then those files are generated, right? So you can say here 1,000. Enter. Then let's look at my phone number. Only one. iPhone.txt. Oh, this should be every time it override, right? So I want to make this. I want to append. Then you need to have a double greater than sign. So if you do cat my phone numbers, then you have 1,000 of such numbers. Okay, and now you can find any number. See, using grep. And you can do -C and Is there any number starting with open parentheses and starting with 9 and 0 to 9, and then therefore 2 of those, right? 2 times, because phone numbers start with 9 followed by 2 other arbitrary number and followed by close parentheses. Is there any such numbers? From my phone number. It's not good, and from here my phone book.txt. Those are all 900 phone numbers, right? And then any one of those is starting with 9 again. So those are the things that I ask you to do, the way that we described, right? Those that we described here. I didn't end, but you need to do it further for your homework assignments. All right? Well, this may be a little tough for those who, everybody in this class, but this is real useful. And not many people knows about this, but I wanted to practice. Practice is the most important for you to understand. So practice this to complete your homework assignments, and also in your final exam, a little bit of this regular expression will be asked. So practice is very, very important for you to prepare for your final exam. All right? Good luck. I'm going to stop here. I'll see you next week.